Chapter 11 starts by discussing correlation. 11a, I think, it's pretty straightforward, and if you guys would like, you can go through and read the textbook about 11a. So I'm actually just going to show the textbook under the video and kind of talk through some of the main points. So it says that correlation refers to the relationship or association between two variables. So correlation is determining how two variables are related to one another. We can have different directions for a correlation. So they can be positively correlated, meaning that as your x value increases, so does your y. They could be negatively correlated, meaning that as your x value increases, your y value decreases. So notice that the dots aren't necessarily forming a perfect line, but we have this line of best fit drawn, and you would have discussed line of best fit in Algebra 1. So they can be positively correlated with a positive slope, negatively here, or potentially data could have no correlation, so no relationship between the two variables. Even if data has a correlation or a relationship between the two variables, it's not always linear. So we're going to be looking at a strategy to determine whether data is related linearly, and so this is what it would look like. So these points are roughly linear. So as the x value is increasing, the y value is increasing at a constant rate. Where these points don't necessarily follow a linear trend, they sort of increase quickly at the beginning and then less quickly near the end. Okay, so these are these would have maybe a different type of correlation that we're not really going to talk about, but this data over here would be more linear, okay, a direct correlation between the two. Our correlation can have different strengths. So data that has a strong correlation is going to be tightly grouped close to your line of best fit. So it's almost forming a straight line. Moderately correlated is going to be also in a line, but more spread. So there's more variance between the data values and the line. It's a little more spread out, but you can still tell it's increasing, and it's increasing at a constant rate. And then data can be weakly correlated. So this data is showing that it has a positive trend, but it's very weak, so it's not clustered together closely. Okay? We have the same strong, moderate, and weak with our negative correlations. It's just as x increases, y value is decreasing. So it could be strong, meaning it's close to a straight line, moderate, has a little more variance from the line, or weak, negative correlation. When we're talking about this data, sometimes we have outliers, and outliers need to be typically excluded. So outliers are points that don't follow the trend line. So this point right here is considered an outlier because it's very far away from the line. It's a singular point out on its own that's not following the pattern that these other points are following. This point, however, is not an outlier. So this point is on this line that's approaching it. It is separate from the data values, but it is in line with them as far as our line of best fit is concerned. So that's the difference. Okay, outliers are far away from the line, where this one is far away from the data points, but it is in line with them. This is a big point, especially as we're talking about your IA, is that just because you find that data has a correlation, that two variables are correlated, it doesn't mean that they cause one another. So we have to be very careful when writing the IA that we don't indicate that because of one we now believe that they cause one another. So what do I mean by that? Here's an example. It says the arm length and running speed of a sample of young children were measured, and a strong positive correlation was found to exist between the variables. So that would mean that the correlation shows that the greater your arm length, the faster you can run. Okay? So the greater arm length, the faster you can run. So does this mean that short arms cause reduction in running speed, or that a high running speed causes your arms to grow long? This would clearly be nonsense. Okay? So we need to be careful that just because they are related or even linearly related, that they don't necessarily cause one another. So we can't say, all right, well, I'm going to get my kid to run faster. I'm going to teach him to run faster, and then his arms will grow longer. Okay? Okay, that's not what we're talking about here. This is saying that the correlation is actually because of the fact that the kids with longer arms are in fact older. So the book gives a second example of being careful with correlation and causation. You can read through that, but just know that just because you find that the correlation is high between two variables, that they have a strong correlation, doesn't mean that they cause one another. So the famous, I guess the one I always hear, I don't know if it's famous, problem that is saying that as ice cream sales increase, the temperature increases. So does that mean that because more people are eating ice cream, that causes the air temperature to increase? Okay, so being careful of the direction of the causation, or just they don't cause one another. We can simply say they are or are not correlated with one another. Okay, so that's section A. Section B, we get into more of the numerical aspect of putting a number to correlation. So in this section, we have what we call the Pearson correlation coefficient. In your textbook in section 11B, it gives you a formula for this, and that is icky. Okay, so we are not going to do any practice problems in class over this. However, if you want to use the Pearson's correlation coefficient in your IA, then you are going to need to reference 11B, okay, where they explain how to calculate it by hand. This is on page 324. And there will also be a document that I send out as it gets closer to, actually running the data for the IA. There'll be a paper that I give you that walks you through an example of how this is done. So if you are doing the Pearson's correlation coefficient in your paper, you must calculate it by hand. Must. However, in both of the papers, the paper 1 and paper 2, you guys have access to a graphing calculator, and we're going to use the graphing calculator to find this value. So the Pearson's product moment correlation coefficient R. So what is it? So the sign of R indicates the direction of correlation. So our R value for Pearson's correlation coefficient will always be between -1 and 1. Okay? The closer the R value is to 1 or -1 determines how strong of a correlation it has. So if we are close to 1, it's strong. If we're close to 0, it's weak. Positive values if R is positive, that indicates a positive linear correlation. If R is negative, indicates a negative linear correlation. Okay. So this chart, and you can write it all down if you want, but it's in your textbook on page 321, shows you that if you get an R value of 1, it means your dots are in a perfect line. That is not going to happen very often. Okay. If you have data between a 0.95 and a 1, you have a strong positive correlation. Notice we have the same thing, but with negatives indicating a strong negative correlation. The closer you are to 1, the stronger your correlation is. So as we move down to 0.87, you're still strongly positively correlated. If we're between a half and 0.87, then it's moderate. After that, as you get lower than a half, closer to 0, we're weak correlations, and then no correlation here and here. Okay, and then in your negatives, it goes the opposite direction. Okay, the further you get from 0, the stronger the correlation is. Okay, so these are some good ranges to reference to indicate what words to use, how to describe that correlation, whether it's linear or not. Okay, so we're going to find out how to find this value from a graphing calculator. So I'm going to pull a question from the textbook. And let's see, example. they give a list of students. And they say phone calls received. They've collected 2 pieces of data. They're comparing the number of text messages and the number of phone calls received. So there's a bunch of students that they gathered data from. So they labeled the students using letters. Right? And then they said, okay, so student A in a certain day had 4 phone calls and 6 text messages, 7 phone calls and 9 text messages, 1 and 2. Oh, I skipped one, but if you're probably not looking in the book. 3, 0 and 2, 2 and 8, 2 and 4, and 4 and 7. And so our question is are these correlated? What's the relationship between the number of phone calls a student receives in a day and the number of text messages that they see in a day, or they receive in a day? So is it that the more phone calls you receive, the more text messages you receive? I don't know. Is it the opposite? Maybe the more phone calls you receive, now you don't have to text people because you're talking to them on the phone. So maybe it's going to be negatively correlated. And so that's what we want to figure out. One thing that you might be asked to do is to make a scatter diagram. So I'm going to start by making a scatter diagram for this problem. I'm going to make phone calls my X, text messages my Y. And so my Y values need to get up to 9. Alright, so phone calls. I just picked phone calls to be my X because it was listed first, and text messages to be my Y. And we're going to plot the data values. I'm just counting by ones here. So 4 phone calls. There's 4. That student A, received 4 phone calls and 6 text messages. 4, 1, 2, 3, 4, 5, 6. There's their data point. Okay, so this is 6. Let's see, 7 and 9. 4, 5, 6, 7. With 6, 7, 8, 9. Okay. 1 and 2. 3 phone calls and then 5 text messages. 0 phone calls, 2 text messages. 2 phone calls, 8. 2 phone calls, 4. And 4 phone calls, 7. Okay, visually it does look like this data is generally increasing. This data point appears to be a slight outlier. If I were to kind of sketch in a line of best fit, it would probably go something like this. Okay, we're not doing lines of best fit yet. We will be doing that into the coming chapters, but that might be a kind of an idea of where the best fit would be. This one seems a little far away, like a little bit of an outlier potentially. So we're going to calculate the Pearson's correlation coefficient. I do expect it to be positive. So these data values do appear to have a positive relationship, but let's see how strong. So to do this, I'm going to set my graph off to the side. We're going to follow some buttons on our calculator. So here they are. So we're going to press stat. This is the same place we went to for one variable statistics, which finds mean, median, mode, standard deviation, quartile 1, quartile 2, median, max, min, that type of thing. Okay. So stat, edit, and I might have already put these in here. Okay, which I think I did. So what you're going to do is your X value, your first list, is going to be your phone calls. So I'll just type them in again. 4, 7, 1, 3, 0, 2, 2, 4. Okay, so there they are. Scroll over, you're going to type your Y values into your list too. Okay, 6, 9, 2, 5, 2, 8, 4, 7. Okay, notice they're all paired up. The 4 and the 7 are together. They were here. The 0 and the 2 are together. They were here. Okay, so these are all of these points put into my stats edit, my list, list 1 and list 2. So we are going to go stat, calculate, and this time we're going to use number 4. I'll write these steps down. So press edit, input data into list 1, list 2. Then we press stat again. We go over to calculate, number 4, linear regression, AX plus B. Enter. The only two pieces you need to fill out are your X and Y list. My X list is list 1, my Y list is list 2. And we enter all the way down to calculate. If, let's say this said list 3, or maybe it's not there at all, your lists are in blue above the numbers that they go with. So list 2 is right here above 2, so we'd press second 2, and it'd put list 2 there. Okay, so you might need to put that into your calculator. You press calculate. Okay. Now, there's a good chance that your calculator is only going to show A and B. I don't know why they make you turn this diagnostic piece on to show you your R value, but they do. So I already turned mine on, but if yours did not show this R or this R squared, then you need to follow these steps. So you're going to go to the catalog, which is over 0. So second 0 brings you here. I want to go to diagnostics. So there's a button. This one has a green D above it. If you push that, it jumps to the D's. And I'm going to scroll down to here, diagnostics on. Press enter, enter, and that turns that R value on. So now whenever you go stat, calculate, linear regression, enter, 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 your R value should appear. So I end up getting, so might need to turn okay, I need to turn diagnostics on. Okay, just getting all the information so you have it there. And I get the main values that matter here, or the main value that matters today is R, which is 0.816. Okay, so what does that mean about our data? So it is positive, which I said that I thought it would be because the data values on my graph do appear to be trending upwards. The more phone calls you receive, the more text messages you receive. If I look in my textbook, back to this chart describing the R values, I got 0.81, 0.7 to 0.95, 0.8 would fall here. So it has a strong positive correlation. So we could make a summary statement about this data saying has a strong positive linear correlation. Okay, so our R value here indicates that it has a strong positive linear correlation, that they are correlated, that as one increases, so does the other. Now, what we're not saying is that the reason why they increase, okay? So, phone calls increases when text messages does because the more extroverted you are, the more phone calls and text messages you receive. Okay, the less extroverted, the more introverted you are, maybe the fewer. I don't know. I just made something up. But we're not saying these grand statements. All we're saying is that it tends to be that the more phone calls you receive, the more text messages you receive. I don't know why, but we're saying that tends to be the trend. Okay. All right, so follow those steps in the calculator to find your Pearson R value. Keep in mind that if you decide to do this for your IA, which is a great topic to do for the IA, it just means that you have to calculate it by hand, and that's no problem, okay? We can handle that. It's just, I don't want everybody to get bogged down in that. I just want, if you're going to do this, we're just going to you're going to focus on that, okay? Where if somebody is going to choose to maybe do a later statistics analyzing tool, then they will focus on that one. And so for now, just stick with that calculator, finding those R values, determining your core. Thanks for watching.